A Tier 1 telecom operator processes over 100,000 customer queries every single day. Users expect an accurate resolution in under 10 seconds. This graph plots interaction volume against human agent capacity. The exponential curve is accelerating queries. The flat line is the fixed limit of human teams. Scaling linearly is impossible. At this intersection, volume outpaces capacity. This is the 40% drop-off point, where queries go unanswered. Managing this support paradox requires a non-linear architectural strategy. Adding more personnel to a linear team structure cannot close a gap of this magnitude. For years, the default patch for this gap has been legacy automation. These systems operate on rigid decision trees and exact keyword matching, but human conversation rarely follows a fixed tree. When a customer uses regional slang, asks a three-part question, or makes a typo, the keyword logic fails to interpret the intent. This triggers a routing loop. Unable to resolve the issue natively, the bot provides a generic web link, forcing the user out of the chat window and increasing the likelihood of abandonment. To handle modern request volume, we must transition to an action-oriented cognitive engine. A high-capacity enterprise solution must execute three parallel functions: understand native language intent, execute secure database transactions, and detect human emotion instantly. The architecture begins at the ingestion boundary. A high-speed front-end framework receives concurrent user queries across web widgets, native mobile apps, and WhatsApp channels. Most AI layers utilize English-optimized translation filters. However, when a user speaks in a regional dialect, like East African Sheng, standard translation strips away the contextual meaning. To maintain accuracy, the incoming text passes into a polyglot natural language understanding node. This neural network natively processes dialectical morphology, categorizing mixed language strings into hundreds of specific pre-trained intents in under 20 milliseconds. It also employs anaphora resolution. By appending a stack of previous data packets to the current query, the system retains conversational context for up to 50 turns. If a user asks, "How much is it?" the engine identifies exactly which telecom plan it refers to based on the history. The front end is built for native right-to-left processing, dynamically mirroring the entire visual hierarchy to match the reading direction for Arabic and Hebrew speakers. Deploying raw generative AI in regulated sectors like telecom and banking introduces a specific compliance risk: hallucination. An AI inventing a fake roaming policy is a liability. The architecture prevents this using Retrieval-Augmented Generation, or RAG. This mechanism anchors the large language model directly to verified corporate documentation. During ingestion, policy manuals are chunked and mathematically converted into high-dimensional vector embeddings, which are stored in a centralized database. When a query arrives, the system executes a nearest neighbor semantic search. Even if the keywords don't match exactly, the mathematical proximity aligns the user's intent with the precise factual vectors. The large language model then synthesizes these retrieved facts with the ongoing conversational context to formulate its response, providing direct source links for every claim. This pipeline enforces factual integrity. The model's output is constrained to verified data, allowing it to handle sensitive banking protocols without improvising policy details. Answering a question is only part of the interaction. If a user asks to pay a bill and receives an external link, the friction point remains. The engine must be able to execute tasks. Veebot integrates a transactional module that connects directly to local payment gateways and legacy telecom mainframes. This parallel pipeline bypasses the language model entirely, securely routing PCI DSS compliant payment processing through an API node straight into the backend systems. This connection allows the bot to fetch live backend data, like a real-time balance check or a recent transaction history, and render it as an interactive visual card directly inside the chat window. Embedding these transactional rails allows the support infrastructure to process recharges and bill payments directly, generating measurable revenue from within the chat context. Automated systems often fail to navigate emotional nuance. A frustrated user trying to report a stolen credit card requires a different response than a routine inquiry. To protect brand value, the architecture uses a sentiment-driven escalation engine. This gauge illustrates the system analyzing lexical markers in real time, scoring user frustration on a scale from -1 to +1. As long as the sentiment score remains below 0.3, the interaction proceeds through the automated intelligence pipeline. If the engine detects high urgency words or severe frustration, the score spikes past 0.7. This triggers an immediate bypass, rerouting the user away from the AI and directly into a human agent's unified inbox. This handoff delivers the full 50-turn chat history and the current sentiment score to the live agent, allowing them to take over the conversation with complete context. This logic reserves human agents for moments of high friction, ensuring that complex emotional interactions receive the attention they require, while routine tasks remain automated. Looking at the completed architectural stack, the operational flow is visible. Data packets move concurrently through the polyglot ingestion edge, the RAG pipeline, and the transactional APIs. Deployed by Bank Altech in the UAE for high volumes of bilingual traffic, this implementation handles 60,000 queries a month, resolving 90% without human input. This deflection rate yields over $200,000 in annual operational savings. While these metrics demonstrate the system's capacity, enterprise deployment also requires strict data protection. In sectors like government defense and multinational banking, regulatory mandates often require absolute data sovereignty. To meet these mandates, the architecture deploys in a dedicated virtual private cloud, or air-gapped environment, ensuring data never leaves the national jurisdiction. Within this boundary, an automated redaction protocol masks personally identifiable information, like credit cards and national IDs, before data is logged. This architecture bridges the gap between conversational fluency and back-end execution, moving past the limitations of legacy decision trees. Cognitive interaction provides a framework for enterprises to manage exponential query growth, maintaining response quality without requiring a linear increase in human overhead.